Welcome to the session on binomial distribution. In this session, we shall discuss the binomial distribution, which is a special type of discrete distribution. If x is a discrete random variable, then we say that x follows a binomial distribution if its probability mass function f of x is given by f of x is equal to n choose x p raised to x into q raised to n minus x for x equal to 0, 1, 2, 3 etc. up to n, and f of x is equal to 0 otherwise. Where 0 less than p less than q and p plus q equal to 1. Here n and p are called the parameters of the binomial distribution. In this case, we write x follows binomial distribution with parameters n and p like this. The notation is like this. We can verify this can define a probability mass function, because we know that if f of x is a probability mass function of a discrete random variable x, then f of x should be greater than or equal to 0 for all values of x, and summation over all x f of x is equal to 1. This is the condition for a function f of x to be a probability mass function. Here f of x is defined as 0 or like this NCX p raised to x q raised to n minus x, where x varies from 0 to n. Here p is in between 0 and 1, not q, p lying between 0 and 1. P plus q equal to 1 means q equal to 1 minus p, that is q also lying between 0 and 1. Therefore, this term cannot be negative, that is the defined f of x is greater 0 or this is always greater than 0 for every values of x. Now, the total PMF, that is summation f of x is equal to if we substitute values of x in this, we get NC0 p raised to 0 q raised to n minus 0 plus for x equal to 1 this is NC1 p raised to 1 q raised to n minus 1 plus NC2 p square q raised to n minus 2 plus etc. plus for x equal to n this is NCn p raised to n q raised to n minus n, that is equal to NC0 is 1. Here note that NCx, the definition of NCx is equal to n factorial divided by x factorial into n minus x factorial, where n factorial is 1 into 2 into etc. up to n. If n not equal to 0, if n equal to 0, 0 factorial is 1. Therefore, NC0 is equal to 1, p raised to 0 is 1, this is q raised to n, first term is q raised to n plus NC1 p into q raised to n minus 1 plus etc. plus ncn is again 1, p raised to n into q raised to n minus n is q raised to 0, that is 1. This is equal to, this is the binomial expansion of q plus p all raised to n. That is summation over all x f of x is equal to q plus p all raised to n. Here q plus p is equal to 1. Therefore, this is equal to 1 raised to n. This is equal to 1. That is the total probability is equal to 1, which is the condition for f of x to be a PMF. Therefore, both the conditions are satisfied by this function. Therefore, this is a PMF. We just verified the given function is a PMF. Here the function is f of x is equal to ncx p raised to x q raised to n minus x, where x varies from 0, 1, 2, 3 up to n and 0 otherwise. This is the PMF of binomial distribution. If we put x equal to 0 here, we get nc 0, p raised to 0, q raised to n minus 0, which is the first term of the binomial expansion of q plus p all raised to n. If we put x equal to 1, this term will become nc 1, p raised to 1, q raised to 1, which is the second term of the binomial expansion of q plus p all raised to n, and so on. Therefore, this function is named as binomial distribution. That is, the terms are in the binomial expansion of q plus p all raised to n. That is why this is called binomial distribution. Now, the expectation of binomial distribution is, by definition, expectation or mean of binomial distribution. Let x follows binomial distribution with parameters n and p, then f of x equal to this. By definition of expectation, expectation of x is equal to summation over all x, x into f of x. That is equal to summation over all x, x into f of x is here ncx, p raised to x, q raised to n minus x. That is x varies from 0 to n, x equal to 0 up to n. This is equal to summation x varies from 0 to n, x into, by definition of ncx, it is equal to n factorial divided by x factorial into n minus x factorial, where n factorial equal to 1 into 2, 1 into 2 into etc. into up to n. For n not equal to 0, if n equal to 0, n factorial equal to 1. Therefore, by definition ncx is n factorial divided by x factorial into n minus x factorial, p raised to x, q raised to n minus x. This is equal to summation x varies from 0 to n, x into, here we write n minus 1 into n minus 1 factorial into n. N factorial is 1 into 2 into etc. up to n. here the previous term is n minus 1 into. Therefore, we can write this as n minus 1 factorial into n. And factorial is n minus 1 factorial into n divided by x factorial is x minus 1 factorial into x into n minus x factorial into p raised to, we write p raised to x minus 1 plus 1, that is in the power of p we just add 1 and subtract the same into q raised to n minus x. This is equal to, here x and x cancelled, therefore, the summation x is varies from corresponding to 0, the terms are cancelled, therefore, x can be taken from 1 to n. Here n minus 1 factorial, this n can be taken outside of the summation, because summation for all x, therefore, n is a constant that can be taken outside. Similarly, p raised to x minus 1 plus 1 can be taken as p raised to x minus 1 into p. That is here p raised to x minus 1 into p, that p can be taken outside. Therefore, n into p can be taken outside of the summation. Therefore, E of x is equal to n p into summation x varies from 1 to n minus 1 factorial divided by x minus 1 factorial into n minus x factorial. Here p raised to x minus 1 into q raised to n minus x. Now, we make a substitution for x minus 1, that is we use we put x minus 1 equal to some r. Then here the values of x are from 1 to n. If x equal to 1, then r equal to 0. X equal to 1 implies r equal to 0. And if x equal to n, then r equal to n minus 1. Here n minus x, x minus 1 equal to r gives x equal to r plus 1. Therefore, n minus x is equal to n minus r plus 1, that is n minus 1 plus r, sorry, n minus 1 minus r. Therefore, this is equal to n p into summation r varies from 0 to n minus 1. Here n minus 1 factorial in the numerator divided by x minus 1 is r, that is r factorial. N minus x is n minus 1 minus r factorial. P raised to r, q raised to n minus x is n minus 1 minus r. This is equal to n p into this is the binomial expansion of q plus p raised to n minus 1. Here instead of n minus 1. Therefore, this is the binomial expansion of q plus p raised to n minus 1. If we expand this summation by substituting the values of r, we get the binomial expansion of q plus p all raised to n minus 1. That is equal to n p into q plus p is 1 raised to n minus 1, 1 raised to n minus 1 is 1, therefore, this is equal to NP. That is the arithmetic mean or mean of a binomial distribution with parameters n and p is the product of the parameters n and p. That is E of x is equal to the product of the parameters n and p, that is E of x is equal to n into p. Now, the variance of x, we have to prove variance of x is equal to n into p into q. Expectation of x is np. By definition, variance of binomial distribution. Let x follows binomial distribution with parameters n and p. Then f of x equal to this, and by definition of variance, we write v of x is equal to variance of x is equal to, in terms of expectation, it is e of expectation of x square minus expectation of x the whole square. Here expectation of x is n into p, we just proved. Now, we want to find e of x square. Expectation of x square. We write x square as x square minus x plus x. That is, we just add x and subtract the same. This is equal to x square minus x plus x. That is, we can take x outside, then x into x minus 1 plus x. Therefore, e of x square is equal to expectation of x into x minus 1 plus x. That is equal to, by the linearity property of expectation, we can split the expectation, that is e of x into x minus 1 plus e of x. Again e of x, it is n into p. Therefore, we have to find e of x into x minus 1 only. That is e of, by definition, expectation of x into x minus 1 is equal to summation overall x into x minus 1 f of x. That is equal to summation x varies from, here variation of x is 0 to n, that is x from 0 to n, x into x minus 1, f of x is ncx p raised to x q raised to n minus x, which is equal to summation x varies from 0 to n. Here for x equal to 0, this the corresponding term will become 0. If x equal to 1, this also becomes 0. Therefore, the variation of x can be taken from 2 to n. X is from 2 to n, summation 2 to n x into x minus 1. By definition of NCX, it is n factorial divided by x factorial into n minus x factorial. P raised to x can be taken as p raised to x minus 2 plus 2. That is, we just add 2 and subtract the same. P raised to x minus 2 plus 2 can be written as p raised to x minus 2 plus p into p square, into p square into q raised to n minus x. This p square can be taken outside, p square into Here n factorial can be taken as n minus 2 factorial into n minus 1 into n. Therefore, this n minus 1 into n can be taken outside, and n minus 2 factorial is putting in the outside of the summation. Therefore, we get n into n minus 1 p square. Summation x varies from 2 to n. Here x factorial means x minus 2 factorial into x minus 1 into x. Therefore, x into x minus 1 will be cancelled. The remaining terms are here. N factorial means n minus n into n minus 1 into n minus 2 factorial. This n into n minus 1 is taken outside. Therefore, the remaining terms in the summation is n minus 2 factorial divided by here x minus 2 factorial into n minus x means n minus x factorial into p raised to x minus 2 q raised to n minus x. Now, we use the substitution x minus 2 equal to some r. We use the substitution x minus 2 equal to r. Then, for x equal to 2, this r will become 0. X equal to 2 implies r equal to 0. Here the upper limit is n. For x equal to n, r equal to n minus 2. X minus 2 equal to r gives x equal to r plus 2. Therefore, n minus x is equal to n minus of r plus 2, that is n minus 2 minus r. Therefore, this will become, this is equal to n into n minus 1 p square summation r varies from 0 to n minus 2, n minus 2 factorial divided by r factorial into here n minus 2 minus r factorial p raised to r, p raised to r, q raised to n minus 2 minus r. This is the binomial expansion of q plus p raised to n minus 2. That is e of x into x minus 1 is equal to n into n minus 1 into p square. This is q plus p raised to n minus 2, which is equal to n into n minus 1 p square. Q plus p or p plus q is 1. 1 raised to n minus 2 means 1. Therefore, expectation of x into x minus 1 is equal to n into n minus 1 into p square. Substitute this value of e of x into x minus 1 in this expression for e of x square. We get expectation of x square is equal to n into n minus 1 p square plus expectation of x is np. And therefore, variance of x is equal to, we substitute the value of e of x square in this expression, we get variance of x is equal to E of x square is n into n minus 1 p square plus np minus E of x the whole square, that is np the whole square. This is equal to n into p square is n square p square. N into minus 1 p square is minus n p square plus np minus this is n square p square, which is equal to n square p square minus n square p square is 0. Here we can take np in common. Therefore, this is equal to np into here 1 minus here p, that is np into 1 minus p. For the binomial distribution, we have p plus q equal to 1. That means 1 minus p equal to q, that is 1 minus p equal to q. We substitute here, that is np into q. That is the variance of a binomial distribution is n into p into q. Therefore, the standard deviation is positive root of the variance. Standard deviation SD is the positive root of variance of x, which is equal to positive root of npq. Now, let me conclude this session. We discussed the binomial distribution and the expectation or the mean of binomial distribution and the variance of binomial distribution. The mean of binomial distribution is the product of the parameters of the distribution, and the variance is the variance of x is equal to n into p into q. Thank you for watching this class. Have a nice day.